Hi everyone, in this video I'm going to be walking you through a very interesting LeetCode problem that was seen in the weekly contest. It's a very interesting variation of dynamic programming and binary search. So without further ado, let's begin. So let's start by going over the problem. Maximize the profit as the salesman. So you're given an integer n representing the number of houses on a number line numbered from 0 to n minus 1. Additionally, you're given a 2D integer array offers where offers of I is equal to start I, end I, and gold I. So indicating that ith buyer wants to buy all the houses from start I to end I for gold I amount. So what this means is that if there is a particular start and end given to us, then we cannot like take from start to end minus one, or we cannot take basically a subset of this. We have to take all of the houses. Basically, you have to buy all of the houses from start till end. And what it is given is that our goal is to maximize your earnings by strategically selecting and selling houses to buyers. So, whenever you're given a question, focus on what the goal is. So, here what we have is we need to return the maximum amount of gold you can earn. So, the goal is to get the maximum amount of gold. Now, let's look at an example. Let's suppose n is equal to 5 and the offers that is given is 0 to 0. So, basically, we have houses from 0, 1, 2, 3, and 4. So we can buy the 0th house for a price of 1, and we can buy the houses from 0 to 2 for a price of 2. So what we have is this much is for 1, and from 0 to 2 we have a price of 2. Next up, what we have is that we can buy the houses from 1 to 3 for a price of 2 again. So 1 to 3 for a price of 2. Now what we want to do is we want to maximize the houses. So here the maximize the number of gold. So here what our answer is 3. Now let's suppose how we get this 3. So if we choose this house, it will give us a gold amount of 1. And if we choose this particular buyer, which who will buy the houses from 1 to 3, we will get a gold of 2. So 1 plus 2 would be 3. Now let's suppose what would have happened if we had chosen this particular buyer. Then we would have gotten a price, a gold of 2, but then we would not be able to buy this house as it is overlapping, and we would also not be able to buy this house as this is also overlapping with this particular integer. So from this we can get an idea that what we need is we need a set of non-overlapping intervals, right? And what these non among these non-overlapping intervals, what we can do is we have to select a subset of these intervals. So among the input that is given to us, we need to select a subset of these intervals. And the third goal is we need to maximize the profit, or let's say maximize the goal. So obviously one approach that can come to our mind whenever we have such a problem is brute force, right? So what you can do is at every point you can say that okay, I'll take this house, and then depending on that you can check like if there is some other non-overlapping house, then you can take that as well. But then let's have a look at the constraints of the problem. What we can see is that n is still 10 to the power 5. That means any solution which is equal to O of n or O of n log n will only work. Even O of n square will not work, right? So this brings us to our next approach. What we can do is maybe we can try greedily selecting the houses. So basically we start with, let's take this example. So let's suppose we have this. So here what we can do is maybe we can try greedily selecting the buyers according to the profit. So what I can do is if I sort these houses according to the profit, then this is what the input will then look like. And then what I can say is that okay, I will select the house with the maximum profit and then I will move on. So here what happens is I will select this particular house 0 to 2, and then what I get is I get a profit of 10. And once I select the 0 to 2, I know that I cannot select 1 to 3 and I cannot select 0 to 0 since these are both overlapping with this interval that I already selected. So fine, for this particular example, my greedy algorithm works. As we can see, the answer is actually 10. But then let's suppose there is a case where, suppose I have an interval, okay, and this interval has a profit of 20, and there are some other intervals. Suppose this has a profit of 5, this has a profit of 10, and this has a profit of 15. Now if I try to apply the greedy algorithm, what I will do is that I will select this 20. I'll select the buyer who will give me this 20 gold coins. But if you notice, because of this 20, what happens is that I will not be able to select any of these three intervals. And if I had selected these three intervals, my total profit in this case would have been 30, as opposed to the profit that I get by greedily selecting, which would be 20. So clearly, my greedy algorithm fails. So this is one more thing that you can do whenever you're thinking about greedy. Think about some different possible scenarios and always try to prove your greedy solution before coding it up. So this brings us to our third step, that is, if greedy doesn't work, what else will work? So what we can see is we need to maximize the amount of profit, right? And we have to strategically select. What this means is that for any particular buyer, I have two choices, and either to choose this particular buyer or don't choose this particular buyer. So whenever there are some choices such as choose or don't choose, that means this is a clue for us to apply a DP algorithm. Since DP, what it will do is that it will explore all the possible states, and for each state, what we will do is we will have these two options, whether to choose and don't choose, and basis that solution that we have, we will be going forward with the next state. So in this algorithm, what I'll have to do is, first I will have to sort these houses according to the start point, right? So suppose I have some houses, and like 0, 1, 2, 3, 4, 5, and 6. Let's suppose I have some houses like 1 to 2 for a price of 4, and 0 to 0 for a price of 5, and 3 to 6 for a price of 4. Now, if I don't sort this particular list that I'm already given, what will happen is I will directly start applying my DP algorithm from here. So so what I will say is that, okay, I'll choose 1 to 2. And then what will happen is that I will move to 0 to 0. But for the 0 to 0, what I'll have to do is I need to verify that the previous states are not overlapping. And how do I do that? How do I keep a track of all the start and end states? Because from our question, what we can see is that n is still 10 to the power 5. So even if I apply a DP algorithm, at max, I can only store one particular parameter, and that will be the index, right? So let's suppose what happens when we sort this list. Then we have 0 to 0, right? And after that we have 1 to 2 for a price of 4, and then we have 3 to 6 for a price of 4 again. Now at any if now what happens in this is that when I start applying the DP algorithm, let's suppose I apply a choice for this, whether to select it or don't select it. And if I select it, then what I can do is, since I know that my list of arrays is sorted, what I can do is I can directly binary search over this remaining list. So let's suppose if I'm at an index, right? If I'm at index, then what I can do is I can apply a binary search from index plus 1 till the end of the array. Since I know that if my starting point right now is, let's suppose, some x, I know for a fact that all of the later on starting points, they will be greater than x, right? So it will be x plus 1, x plus 2, but it will be greater than x. So this is our cue to apply a binary search. So basically, after sorting the array, what I can do is I can apply a binary search to find the next point. So let's suppose how we will apply the binary search is that we will find a midpoint, right? And what I'll do is I will check if the midpoint, if the start of the midpoint that I'm at. So let's suppose I have an array of mid, right? Array of mid comma 0. That means the start point. If it is greater than my current end, then I know for a fact that all the elements that are after this mid, they will also be all of the elements which have a which are at after this midpoint, even they will have a start point greater than this current end, right? So what I can do is I can store that, okay, my result will become equal to mid, and maybe I can try searching on the left side to find even more possible points, right? So what I'll do is I'll set high is equal to mid minus 1. And let's suppose the other case that my area of mid comma 0, basically the current start point that I'm at, if it is less than or equal to end, then what that means is that, or this particular point is not eligible to be my next possible index, right? In that case, what I'll do is I need to search on the right side, because I know for a fact that the start points are strictly increasing, right? So this brings us to our DP solution. Finally, what will happen is, let's move on to the coding part. We will first sort the array that is given to us according to the start point. So this is how you sort an array list in Java. So what I'm doing is I'm sorting the input list according to the start point that is given to me. Since what I need is I need all of the start points to be strictly increasing in order. Now let's go ahead and code up our DP solution. I will have one parameter index which represents the current index I'm at, and this will be the list of integers, basically the sorted one that is given to me as input. Now obviously let's first code up the base case condition. So if I have reached the end of the array, that means I have explored all possible options and I can just return 0. Now in DP we have two options, choose and don't choose. So for the don't choose condition, let's suppose the answer would be answer 1. What I'll do is I will directly ignore this index and I will move on to the next possible index. So that is the simple code for this particular part. Now we have the tricky part, which is a choose point. Now if I choose this particular point, I know for a fact that I would be getting at least offers.get index.get to. I would be at least getting this particular profit for sure. Or let's suppose, as in the question it is written, gold. So I would be getting at least this much profit. Now what I need to find is I need to find the next possible point where the start point does not overlap with my current end point, right? So this would be my search range, and let's suppose next possible index would be equal to offers.size. And now what I'll do is I'll apply a binary search over the remaining range. So first I'll find the midpoint, and now what I'll do is I will check for this particular midpoint. So if the offers.getMid.get 0, what this means is that if for the current index I'm at, the start point is strictly greater than my current endpoint, offers.getIndex.get1, then what I can do is I know that this mid can be one possible starting point, and now what I want to do is I want to see if there are some indices which I'm missing and which can also be included in my answer. So basically if I can expand my search range. So for that case what I'll do is I'll set my high is equal to mid minus 1. Now the else case condition will be when my midpoint is overlapping with my current index, with my current interval range. So in that case, what I'll do is I need to search on the right side, because I know that this particular search range is no longer applicable. So in that case, I would say low is equal to mid plus 1. And then finally, in my answer 2, what I will do is I will say answer 2 plus equal to false. We have next possible index. So next possible index and offers. And finally, what I have to do is I need to return the max of both these possibilities, answer 1 and answer 2, basically the choose and don't choose condition. Now let's call this function in the main point. So we are yet to, as we can see, we are getting a correct answer. And this is a recursive solution. But what we need to do is we need to apply DP. So what I'll do is I will just memoize this particular problem. What I'll do is I'll take a DP array, right? And this DP array would have a length of offers.size. Let me just fill this particular DP array with -1. And then in my recursive function, I will just simply check if DP of index is not equal to -1. That means if I have already previously solved this particular DP state, then I can directly return the answer that I had already solved. And if that state is not solved, I will solve this particular state and I will also store it in my DP array so that it can be used later on. So that's it. You just have to write the recursive solution, and the memoization part is pretty simple. You just have to take a DP array and then store the answer in your DP array. And as you can see, this answer is correct. So this is how you solve this very interesting. So that was the explanation for the problem. Let me know in the comments if you understood this problem or not. And what was the one thing that you learned from this particular video? And if you want to know anything more, if any other topics you would like me to teach, then let me know that as well in the comments. Thank you.